Alright, so this is part 4 of integral problems with polar. There's a couple more, a little trickier problems that I wanted to cover, so I'm going to extend this longer than a 3-part series. So we want to find the area enclosed by r equals 3 sine theta and r equals 3 cosine theta, and I have the graphs up here. Okay, we've already dealt with graphs like this in past videos, specifically the last video, so I figured I'd already put them up here. Now, here's the idea. We already know the angle of intersection. Okay, that's pi over 4. Okay, we know that. But we can't do just a regular two-curve, area between two curve problem because there's no top function or bottom function. Okay, so we're going to have to think of this in a different way. Now, if you notice, if we take the integral from 0 to pi over 4 of 3 sine theta, that's actually going to give us this area right here. Okay? It's not going to take any of this other area because that's not part of 3 sine theta. Okay? So we can't extend this any farther than pi over 4 because we're starting to interfere with this bound here that we're worried about, which is the 3 cosine theta, right? That's the other curve that's bounding this area, right? So all we have to do is just double this area, and then we have the area of the whole entire thing. All right? So it's not, if there's no top function, then you're going to have to start thinking, other methods, I guess. So since we want to multiply this area by 2, the 1/2 that usually sits outside the integral, well, that's just going to go away. So we're going to get the integral from 0 to pi over 4 of, well, now we're just going to be dealing with that sine theta. And it's kind of weird that we're not incorporating this cosine theta at all, but that's because that if we were to do that part, well, that's going to be the same area as the part that we're trying to find now. Okay? There's symmetry, right? Now, the integral from 0 to pi over 4 of what? Well, we're going to have that 3 sine theta, and that's going to get squared. So we're going to have a 9 sine squared theta d theta. Pull that 9 outside, we get 9, the integral, from 0 to pi over 4 of, we use our half angle identity here. That means that we're just going to have an over 2 on the outside and a 1 minus cosine of 2 theta d theta on the inside. We can integrate here. That's going to give us 9 over 2. We're going to get just theta minus sine of 2 theta over 2, evaluated from 0 to pi over 4. Okay, just plugging in here, well, 0 is actually just going to kill off everything, so we got to worry about that pi over 4 now. We get 9 over 2 times pi over 4 minus sine of 2 times pi over 4, that's going to be pi over 2. We're going to divide that by 2. Well, what's that going to be equal to? We can just do a 9/2 times, this will be a 1, right? Sine of pi over 2, that's just 1. So we're going to get a 1/2 in there. We get pi over 4 minus 1/2. Okay? And we can just, I guess, distribute here to get, we're going to get 9 pi over 8 minus, we just get a 9 over 4. Alright, so that's basically it, alright? Nothing too hard, just figuring out how we're actually going to integrate that piece right there. So that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar, the explanation video for integrals with polar, in the next video in the series. See you soon.